Hello everyone. Let's look at today's Leetcode problem. 1298 maximum candies you can get from boxes. Before starting this problem, let us look at a motivational quote for today. Life will challenge you, people will doubt you. You should never doubt yourself. You are the only person who knows exactly what you are capable of. Every expert was once a beginner, every confident person has walked through fear. Every success story includes chapters of struggle, failure, and loneliness. Believe in oneself not because they always felt confident, but because they chose not to quit. You do not need to have all the answers, you just need to take the next step. Progress is built one small move at a time, not overnight. Let us look at the problem statement. Uh, but yeah, this big lengthy motivational quote gives us a lot of meaningful insight on how we would have our uh, daily challenges and why we should always have self belief. So yeah, before okay, so let's start this problem. Let us understand the problem statement. You have n boxes labeled 0 to n minus 1. You are given four arrays: status, candies, keys, and contained boxes, where status of I is 1 if the box is open and 0 if the box is closed, and candies of I gives the number of candies at the specific ith box. Keys of I is a list of the labels of the boxes you can open after opening the ith box. Contained boxes is a list of boxes you found inside the ith box. Okay, so you are given an integer initial boxes that contains the label of the boxes you initially have. You can take all the candies in any open box, and you can use the key in it to open new boxes, and you also can use the boxes you find in it. Return the maximum number of candies you get following the rules above. Okay, let us understand with an example here. Uh, so, so there are these set of values: candy, status, keys, and contain boxes and initial boxes. So we would be starting from the box 0. We would be looking at status of the box, which is 1, and we can pick the candies at 1, which is 7. So our initial candy count will be 7, and from here we can also look for the contained boxes, which are 1 and 2. So we can obviously explore the boxes 1 and 2, and let's see what 1 and 2 has. So 1 has a status of 0, and this has a status of 1. So we can open this box, which has a candy count of 4. So we can say 7 plus 4, while we also see a keys here, so which allows us to open this box, which is unexplored. So that makes this box also to be have a status of 1 or open, which means we can also pick this candy. And after opening this box, we do not see any more keys. That means we would not be able to open the last box, which contains 100 candies, while our output value would be 7 plus 4 plus 5, which would be equal to 60 as per the output that we see here, right? That's the example that's given. So similarly here in this part where we are given with an initial boxes of 0 in the example 2, we can open this box as it has a status of 1, and our initial candy count at 0th position is 1. From the one box we can open 1, 2, 3, 4, 5. So which means 1, 2, 3, 4, 5, right? So we can also uh, find the keys for all of these, which means we can change all of these boxes 1, 2, 3, 4, and 5. So which means all of these has a candy count of 1, so which means we can open all of these boxes and pick the candies from them, which means we end up with a total candy count of 6, and that's where we see this output. Okay, so let's look at how we can solve this problem. There is a bunch of constraints here, which I don't think so is meaningful to look into, but yeah, let us look at an approach on how we can solve this problem. Okay, so let's use BFS to solve this problem, where let's say we start off with the initial box, and so we start off with the initial box, we check initial boxes has any specific box which has a status of 1, so that we can open it, and we push this box as a starting point. Let's use BFS, and we push this first initial box, and we also keep track of the total candies, and we use a while loop to explore or perform BFS, where we check every time if the queue's length is empty or if we have explored all the boxes, and here we add candies, and also check for any specific keys that we have. Uh, like for example, we had any specific keys at the specific box, right? So we take this key and we keep track of has any key, so that we can use this for later. And if we have a box and not seen with the key, then we also push new unexplored boxes uh, with the key, right? So that's one thing. uh, Next thing will be if, okay, so let me write it in a new page, where first thing is we check all of the initial boxes, and let's say we queue the initial item, and total candies would be there, so we add candies for the current box, and we check if there is any key available, and if uh, has a boxes which need a key. So let's say if any previous boxes need a key and it's unseen, then we queue the box uh, with the new key that we can unlock with. So this is one part. While we also check with the contained boxes. So contained boxes, and we check for new box and we explore the box if it has a key of open and status of open. So with all these, we also keep track of a seen box so that we do not iterate it multiple times, and at the end we return total candies for all the boxes that can be visited or that can be checked. So this might be our approach. So let's try implementing it in the Leetcode editor and let's try solving this problem. This would be an array to keep track of the boxes if it's already visited, and we got few more arrays which helps us keep track of has any boxes and where we need a key to open it or its status is not open and we can use a key to open it. So that's what is going to be tracked with this array, and we also keep track of has key in the same similar kind of array. And so we want to explore or we want to see what are the initial boxes, and let's queue them into the queue so that we can perform BFS on it. And we mark the specific box which we explore each time as visited, and let's also have a total candies. and we check if there are any keys that can be used for further opening any of the boxes. So we and we also check if any boxes that require key and they are unvisited. Next, we also uh, check for any boxes that are contained with the specific boxes within the specific box that we are exploring. So we mark this box which is contained inside this box as visited, and we also push it to the queue for further exploration as we go along. And we are checking if this box can be opened or we have any key that we can use to open this box. And it's not seen, it's not marked as seen in the array. So yeah, once we do that, let's add these two. Okay, so this should give us, so we can simply return the total candies after the BFS, and this should return us the expected answer for this question. Okay, so let's try submitting the solution. Okay, so status dot length n. Okay. In the meantime, while we clear all the issues, so the time and space complexity of this solution. Okay, so has new box in line number 27 has box. Okay, we has box, and we are checking for the specific has key. Key. We are checking if it has a key for this specific key, and key boxes key has key. Okay, so we marked we have a specific key and for the specific box, so that we can see if there are any boxes that has a key and also not been explored, so we push them into the array. So that's what we are doing here. Okay, so let's try submitting it again. Okay, as you see, the solution gets submitted. The time and space complexity of the solution would be uh, we would be iterating n times with the status, and also we would also be exploring all of these keys, candies, and contain boxes. So yeah, it would be a bunch of all the lengths of all of these arrays, and space complexity would be of the value n, which is status or the number of boxes, right? If you found this video helpful, please like and subscribe to my channel. Thank you.